Hello, I welcome you all to lesson 2 under moment of a force. And lesson 2 is public on all our social media platforms. I want us to revise through these things and I want us to understand what I will be teaching. We are going to revise through some good questions together, and I just want you to follow me clearly. And those of you that are not under my online lessons, by the end of this particular video, I'm going to share my details and you will be able to join my online classes. I'm here to make science very simple. The question is saying, the diagram below shows a uniform plank of length 100 centimeters kept in equilibrium by different masses. You need to understand that sometimes they will say a uniform meter rule. So the moment you just hear a uniform meter rule, a meter is 100 centimeters. So a meter is 100 what? Centimeters. So don't be confused. So this is a what? A plank of 100 centimeters. So as you can see, if you add 10, 20, 50, 20, this is 100 centimeters, which is a meter rule. Then we've got these questions. So these are the first questions that we are going to start with. Calculate the moment of the 3 kg mass. They want you to calculate moment. I told you in my lesson 1 that moment is the turning effect of a force. So the turning effect of a force can be calculated by using the formula moment is equal to force multiplied by distance. You need to know that the force and the distance should be perpendicular to the force. So you are going to say this is equal to, what is the force? So for you to find the force, you know that force we get to say mass times gravity. So this is what we are going to do. The mass is 3 times what is the gravity? Gravity we use 10 meter per second. Then you say multiplied by, so this is what we are going to do. Multiplied by what distance? From the pivot, where is the pivot? The pivot is here. This is where you have a pivot. So the pivot is where? The pivot is here. So pivot to this force, that is a distance. A distance of what? 20 centimeters. You change that. Since this is in kg, you are going to convert it to meters. So you divide by 100, where you are going to get a 0.2 meters. So you are going to get 0.2 this side, like this. This is what you are going to do. So when you multiply there, so since this is physics, we say 3 times 10, you are going to get 30. The 30 that you get multiplied by 0.2, you need to get 6. So the answer that we are getting here, when you do all your calculations, you need to get what? You need to get 6. So 6 Newton meter. This is the answer. So this is the moment of the 3 kg mass. This is what you are supposed to do. We move now to the next question. I guess you are able to understand even as I'm teaching you. I'm making these things very simple. So I want you to follow me clearly. Those of you under my online lessons, you need to make sure that you are able to write down everything that I'm discussing with you. This question, I gave it as an exercise, and I guess you are able to note certain mistakes and you are able to understand clearly. So where you are making mistakes, I guess you are able to revise through. And those of you that are not under my online lessons, I guess you are getting 1 or 2 things. We started this, so it is just a continuation. We move to the next question. Weight of the plank. You are now taught to calculate the weight of the plank. How can you calculate the weight? For you to calculate the weight, I want you to understand this. You need to look for the center. Where is the center? The center. So since this is 1 meter, So the center, we say, where is 50 going to be? The center, we just approximate. The center must be here. Have you seen? This is where we must have the what? The center. So that is the weight. The point where all forces seems to be acting on. So this is what I am doing. This is what you need to get and understand. From here, since this is where weight is, so this is where the weight is, what you are going to do now, this is where weight is. You now say, okay, the formula I'm going to use here is the principle of moment, which states that the sum of the total moment in the clockwise is equal to moment in the anti-clockwise. So the formula that you are going to use to answer this particular question, you are going to say moment in the clockwise like this is equal to moment in the what? Anti-clockwise. So you know that this one, we are referring to this part. So what we are doing, if I was to cut this, have you seen? I'm cutting, if I say the 50 is supposed to be here, I'm just cutting this. I say the 50 is supposed to be here. This is where I'm supposed to have a 50, isn't it? So if I put a 50 here, I say, okay, 50 is supposed to be here. This is the center. So since this is the center, I'm saying, okay, this is the center. Then I've said that from here, have you seen, from this part. So since this is the center, here this is 10, this is 20. Meaning this gap, this is 20 plus 10, 30. So this gap will be what? This gap will be 20. So that this whole side becomes 50. Then this part also becomes 50. For this part to become 50, then meaning this part, the 50 will go, meaning that here I'm going to have 30 centimeters. Meaning this is balanced. I don't know if you've understood what I've just done. I've cut this into two, like this. I put this. Since I know that this is 10, this is 20. Then this gap, to reach 50, this must be what? 30. So that it becomes 50 this side. Then I know that this is 20. I need to have a 50, so this is 30, so that I need to have a 50. So 50 this side, 50 this side, meaning this is now balanced. The pivot is there. So now I find the moment that is in the clockwise direction. So this is in the clockwise direction. It is going like this. Even this one is in the clockwise what? Direction. But this one is in the anti-clockwise direction. The formula you need to get here, there is another formula that we can use to answer this particular question. So even as we get to move forward, even as we get to advance, I want you to understand, once we find the weight, have you seen, we want to find what? We want to find the weight there, which is more like a force. We want to find a force that is here. It is just one and the same. So what I need to do here is that this one, this is what? This is 1. So I will say 1, have you seen, times what? Times 10. That is what I'm going to do, times 10. That is the force that is there. I say this is going to be multiplied by what? The distance from here to the pivot. This is 30, this is 20. This is what? 50. The 50 that I've gotten, I divide it by 100 because it is in centimeters. So if I divide it by 100, this is 0.5. So I'm going to get here what? 0.5. I say plus. There is also this other one that is in the clockwise direction. So this is W. So I say W multiplied by what distance? From here where it is to the pivot. This is 20. So 20 divided by 100, that is 0.2. So that is 0.2, which is equal to. Now the anti-clockwise, this one that is in this direction, it is like this. So this is anti-clockwise moment. So anti-clockwise moment, this is what I'm going to do. Hope you are able to understand this. This is 3. Have you seen 3? So 3 times 10. I'm finding the force. 3 times 10, that is 30. So here I've got 30 what? Newtons. It is just one and the same. Instead of doing this, so I just say 30 multiplied by the distance. The distance from the pivot, this is what? 20. 20 divided by 100, I'm getting what? I'm going to get 0.2. So this is what I'm going to have. This is the information that I've gotten. Since this is the information, I need to calculate for W, that is the weight. So this is what I need to do. What I'm going to do is that this is what? This is 10, isn't it? 10. 10 times 0.5, that is 5. So I'm going to get 5 plus W times 0.2, I'm going to get 0.2 W, which is equal to, here if I multiply 30 times 0.2, so if I multiply 30 times 0.2, what answer am I getting? I'm getting what? I'm getting a 6. So I'm getting 6 there. Here, this one goes this other side. So this one will go the other side. So when it goes the other side, I'm going to have 0.2 W is equal to 6 minus 5. This is what I'm going to have. I'm solving for W. So this is 0.2 W, which is equal to 1. I divide both sides by 0.2, even here 0.2. So this will be cancelled. I will just say, therefore, W is equal to 1 divided by 0.2. I'm going to get 5. Then I just say newtons. So this is the weight of the what? Of the plank. This one. This is how you get to answer questions in an exam, just like this. So I want you people to follow me clearly and attentively. Maybe you've not understood this particular question. Let us look at another example. Maybe you are going to understand it. And before we proceed, you can have questions like name or state one application of this setup. So the application of this setup is just the opening and closing of a door. You get to apply what? Moment. Moment gets to be applied. You center all those things. So opening or closing of the door. This is the application of this setup. Let us look at another example. I guess you are able to understand these things. This is how you get to answer questions that will come in an exam. So let us look at example 2. So this is example 2. How can you now answer this particular question? The question is saying, the diagram below shows a uniform meter rule. So if you look at this particular question, the way it is, this is a uniform meter rule. So this is what? 100 centimeters. A meter rule, that is 100 centimeters. So it can be balanced by a knife edge, anything. So I just want you to understand what I am doing and the calculations that I am doing here. The question is saying, calculate the weight of the meter rule. How can you calculate the weight of the meter rule? I told you, the first thing you need to do, you need to find the center where all masses seems to be acting on all forces. So it is at 50. This is already at what? 50, which means that the work has been made simple. So this is what? This is already at the center. This side is 50, this side is 50. How can we answer this particular question? To answer this question, since the pivot is here, this is where the pivot is. What I'm going to do is that I'm going to use the principle of moment. So this one that is here, this is in the clockwise direction. It is going like this. This one is anti-clockwise. A clock moves like this. So meaning this one is going in that direction, which is anti-clockwise. So what I'm going to do, this is what I need to do. So I want you to understand the calculations that I'm doing here. This one from here to the pivot, have you seen? So I've got the formula I'm using is force 1 times distance 1 is equal to force 2 times distance 2. So what I'm going to do here is that I'm going to say this one, this is the force, which is 50 multiplied by the distance from here to where the pivot is, where the mass and the pivot. So this is 90, this is 70. The distance there, the difference. What is the difference? What is the difference? The difference is 20. So the difference is what? 20. Since this is 20 centimeters, I need to convert to meters. So I divide by what? I divide by 100. I'm going to get 0.2. So I'm saying 0. What? 0.2, which is equal to. This is equal to now. What is the force that is there? This is the same weight I'm taught to calculate weight times the distance. What is the distance there? What is the distance? Have you seen 70 and 50? That is 20. I do the same. Divide what? Divide the 2. Divide the 100. 20 divide 100. I'm going to get 0.2. So I calculate for W. Then I'm done. This is so simple. So what I'm going to do here, if I multiply, I say 50 multiplied by 0.2. What answer am I going to get? I'm going to get a 10 here. So if I say 50 times 0.2, I'm getting a 10. So 10 is equal to 0.2. Have you seen? 0.2 W if I multiply. I now divide both sides by what? 0.2. Even here, I divide by 0.2. So 0.2, 0.2 cancelled. W is equal to what? This same 10 that is here. So 10 divide 0.2. What is the answer? The answer is 50 what? 50 newtons. So this is the weight. I will just say, therefore, the weight of the meter rule is, the weight is what? 50 newtons. So I'm done. This is what you are supposed to do. Just like this. The same way I'm answering, this is the same way you are supposed to answer. So I've told you that this lesson is public, and even those that are not under my online lessons are able to access it. Just this one. I have done this so that if there are those that want to join, they can join us. So you WhatsApp me on my number. This is my number, 0971 066747. This is my WhatsApp number. So even those that are not under my online school, you want to join, you are a GC candidate, or you are an internal candidate, you want to be helped in maths, chemistry, physics, biology, I'm here to help you. So this is the number you have to WhatsApp. So don't WhatsApp me if you've got a question. I'm saying if you want to enroll, people have got a tendency of getting this number. You WhatsApp me with a question that you want help in. I've told you, if you want to join us, you WhatsApp me. This number is only for those that wants to enroll. So let's follow instructions. Not to get this number, then you text with a question. No, I won't respond that way. Okay, so let us now look at another example. So we go to another example, which is example number 3. I want you people to know this to the point that if you encounter a question like this in an exam, you will be able to handle it and you are going to answer it. Let us look at example 3. So this is another example that we take. Let's see how we can handle this particular question. So what I'm going to do, I want you to pause this particular video a bit. Pause it. Try to answer this question. So this is a self-test. Those of you under my classes, online lessons, I won't give you an exercise tonight because this is the end of this particular topic. I just want you to analyze everything that we've covered so far. So this is a particular question that is here. The diagram below shows a uniform meter rule which is balanced on a pivot by masses. You are given this wonderful question. How can you calculate the value of M? So I want you to calculate the value of M. How can you calculate this value of M? For you to calculate the value of M, so pause this video and answer this question. Okay, I guess you've answered, and let's now see the answer that you found. Confirm with my answer. This is a self-test. You are testing yourself. So for us to answer this, if we look at a pivot, the way a pivot is, where the pivot is, it is here. This is a meter rule. Here we've got 10. This is 40. So this is 10 centimeter, 40 centimeters. It is already on the middle. This is where it is. It is already balanced. Obviously, that is where all forces seems to be acting on. That's where we've got the center of gravity. So what we are going to do, this is something that is so simple. What we are just going to do here, I'm just going to say, okay, for me to calculate the value of m, which is here, I'm going to say this mass that I'm given. So I want to introduce another new formula. I guess some of you've not seen this formula before. So we know that the principle of moment states that moment in the clockwise is equal to moment in the anti-clockwise. So the force that is there, you now understand that it can be mass multiplied by gravity, then this times what? The distance, which is equal to mass multiplied by what? Gravity times the distance. Since mass is different, so we say mass 1, here this is distance 1. Here we put mass 2, this is distance 2. As you can see, gravity is the same. Gravity will always be equal to what? 10 meter per second squared. This is the gravity. So gravity is the same. It's just the same as cancelling the g's. We are just going to have m1 multiplied by d1, which is equal to, then I say m2 multiplied by distance 2. This is to tell you that if you are given the masses, this is a particular formula you can use. So when you are given masses, you can use this formula. So in this question, they want you to calculate the value of m, which is mass, because that is mass, that is mass. Mass is in what? Mass is in grams. So there is no need of converting those measurements that are already in centimeters, because this is in grams. If it was in kg, we convert that to meters. Since it is in grams, there is no need of changing. I guess you are able to understand these things, and we are able to move together. So I guess you are able to answer questions. You are able to answer a question that gets to fall under this part. So what I'm going to do, what is the mass 1? So mass 1, that is 100. So I'm going to say 100 multiplied by the distance from where it is to the pivot, that is 10. So times what? Times 10, which is equal to, I'm going to say m times what is the distance from here to the pivot. Since this is 10, so from here to there, I'm not given, which means I need to have a 40. Have you seen 40? Because this is where the center is. So for 10, 40, 10, 40, discover that it is already 100. So, and this is placed on the center. If this is 10 and this is half meter low. So get this, sometimes they will tell you half meter low. So the center of the half meter low, it is 25 centimeters. Have you seen? So if they say, they give you a half meter low, they say, okay, this is the half meter low. So the center will be on the what? Will be 25. So the center will just be 25 centimeters. That is where all forces will be acting on. But if it is a meter rule, a complete one, meaning that it is 50. It is on the 50. So this is how it is. This is a meter rule. So it is on the 50 here. This is where we've got this. So now what I'm going to do, this is 40. I multiply by 40. So here, what is the answer? What answer am I going to get this side? What answer am I getting? The answer that I'm going to get here, this is what? This is 10,000. I'm going to have 10. I'm going to have 1,000. That's 1,000. So if I multiply, that is 1,000, which is equivalent to what? 40m. I divide both sides. So I'm going to divide both sides by what? By 40. 40, even here by 40. So what answer am I getting? I say 1,000 divide 40. What answer am I getting? I'm getting 25. So I say therefore m is equal to what? 25. I'm getting 25. So meaning that this one here, this is 25 grams as my answer. So this is what I'm supposed to do. This is what I need to do for me to answer questions that get to come in an exam under this part. So I've showed you ways to answer questions. You are able to find the clockwise moment. You can find the anti-clockwise moment. So if a question is like this, the way this particular question is, if I'm told to say, find the clockwise moment, how can I find the clockwise moment? Since this one is already at the center there, so it is only this one that is in that direction. So clockwise moment, I say, okay, this is what? This is in grams. So which means that I can convert it to kilograms. So this is as 0.1. So I can say this is 0.1 multiplied by the distance that is there from here to there. This is 10 centimeters. 10 centimeters in 2 meters, you just divide by 100. So you get what? 0.1. So this is, you say 0.1 times 0.1, what answer are you getting? So if you multiply 0.1 times 0.1, the answer that we are getting is what? 0.01 Newton meter. So this is the moment in the what? In the clockwise direction. And clockwise, it is this one. So you move like this. You are able to do all those things. And I've told you that if it is not on the center, this one, meaning the weight that you get to put, if it is not on the center, even this one will go in the what? Clockwise direction. So you are going to have two moments that will be in the clockwise direction. You just need to understand the way a question is. So if you are taught to find the mass of a meter rule, if you are taught to find it can be a prank, anything. So you are able to answer those particular questions, and you just need to know that you are able to answer them just like that. So physics is very simple, and you need to make sure that you just understand the basics. So this is where we are going to end from. Those of you under my online school, let me now give you an exercise. So I want to give you an exercise. I see how you are going to answer it. So let me give you an exercise. I see if you are able to understand these simple things. So this is where we are going to end from. Like I've told you, this is a public lesson. Even those that are not under my online school are able to see this video. And if you want to join me, this is my WhatsApp number. Just WhatsApp me on this number. If you are not under my online school, I'm going to help you get a distinction in sciences, even mathematics and biology. So this is my WhatsApp number. Don't forget to like this particular video. Don't forget to share it, and let me know where you are connecting from. Thank you so much.